We will now do momentum B, problem number 4. And this problem is going to be a conservation of momentum problem. It says you have a 4-kilogram object. So the mass of object 1 is going to be 4.0 kilograms. And it's traveling westward. So the initial velocity of object 1 is going to be westward. We usually define as negative. In the problem, it states it's westward at 25 meters per second. So we're going to set that to negative 25 meters per second. And it hits a second object. And the mass of that second object is 15 kilograms. And this object, object 2, was initially at rest, 0 meters per second. It says the 4-kilogram object, which is object 1, bounces eastward, which is the opposite direction. So my final velocity of object 1 is going to be 8.0 meters per second. It says, what is the velocity of the 15-kilogram object after the collision? So what is the final velocity of object 2? Remember, in all collisions, it is momentum that is conserved. Energy is not necessarily conserved. So we have to look at the momentum. So the way we set this up is the initial momentum. By conserved, it means it's the same before and after the collision. So before the collision, the total momentum will just be mass 1 times velocity 1 initial plus mass 2 times velocity 2 initial. That's momentum of both objects before the collision. And we need to set that equal to mass 1 times velocity 1 final. So the momentum of object 1 after the collision plus the momentum of object 2 after the collision. At this point, we can start plugging in some numbers. Mass 1 is going to be 4.0 kilograms times velocity 1, negative 25 meters per second. And you add to that your mass 2, which is 15 kilograms, times your velocity initial of that mass, which is 0 meters per second, and set that equal to mass 1, which is 4.0 kilograms still, times velocity 1 final. So after the collision, it's traveling at a positive 8 meters per second. And add to that mass 2, which is 15 kilograms, times the final velocity of 2, which is what we're solving for. So at this point, let's start adding these together. So on this side, I have negative 100 kilograms meters per second. And that's going to be equal to 32 positive kilogram meters per second plus 15 kilograms times the final velocity of object 2. Subtracting 32 kilogram meters per second from both sides, I get negative 132 kilogram meters per second equal to 15 kilograms times final velocity 2. So divide both sides by 15 kilograms. Divide this side by 15 kilograms. And I get the final velocity of object 2 is going to be negative 8.8 meters per second.